Hi everyone. Today in this video we're going to talk about lines, but we're going to do it a little bit differently than you've done it before, and we're going to talk lines using statistical analysis. So we'll figure out what that means, but at the end of this you should be able to figure out slopes, y-intercepts, equations of lines, but also kind of use them to predict trends in real world context. You should know what a scatter plot is by the end of this video and learn a little bit about statistics. Okay, so we're going to talk about linear relationships in the context of analyzing data. Okay, so for this video, we're going to talk about average college room and board, tuition, and fees as it has increased over time. Okay, so the first thing we're going to do is we're going to plot this data on a coordinate plane. So the coordinate plane I have here is years since 1978, and on the y-axis we have cost of attendance. Now, before we can actually plot that, we need to take a look at this data here. Because when you go to college, it's not just room and board you have to pay, it's not just tuition fees, it's both together. So for the cost of attendance, what we're going to have to do is add up these two and figure out what the total cost is. And that's what we'll plot on our y-axis there. So we're going to look for total cost of attendance. And on our x-axis, we have, let's see what it says, years since 1978. So am I going to plot 1978 for years since 1978? No, I'm going to say that was like 0 years away from 1978. So this would be like 0 to 1 year away. And before we move on, I'm just going to pause the video and figure out how many years each of these has been since 1978 and what's the total cost so we can plot that as a scatter plot. So I'm going to pause this. Go ahead and do that on your own, and you can check with me when I come back. Okay, so this is what I came up with for the totals and the years since 1978. Now, I know this is a range of years, but it's really saying how many years has it been since that school year. So you can just say how many years has 1983, or how many years away is that from 1978, which is 5. Technically, you could say 5 to 6 because there were 2 years in the year, but the school starts in 78. So I have 5, 10, 15, 20, so on and so forth. Okay, the reason I had to do that is so I can plot just one variable on our axis here. So years since 1978, you might just label that as you wrote it up there. So this is 5, 10, 15, 20, 25, 30, 35, 40. We don't really need to go on. Okay. Now I calculated the total cost of attendance, and that's in my total column over here. So we need to figure out what's a good scale for our y-axis. So what do you think? Could try and go by like 2,000, be 2,468. I don't know if that's going to be enough. You could try to go by 1,000. Again, there's not going to be 23 tick marks here. So what I'm going to choose to do is go by 3,000. So I'm going to say this is cost of attendance in thousands. Then I don't have to write 3,000 every time. I can just write 3, and then you know it's 1,000. And this is 6. This is 9, 12, 15, 18, 21, 24, 27, and this would be 30. Cool. So now what I want everyone to do is pause the video and go ahead and plot these data points with years being your X and total cost being your Y. Okay, if you plot it, it should look something like this. Now, you may notice that some points are closer together than others. So like these points are kind of close, whereas these are far away. And the question is that because I made an error and I'm not doing this accurately, or is this relationship not perfectly linear? So the way we can test that is just by looking at these values and seeing if there's a constant rate of change. So I can see on the X, we're going up by an equal interval. We're going up by 5s. Now on the Y's, let's take a look. So if I take 4,748 and I subtract 2,918, okay, the difference between those is going to be 1,830. Now let's take 2 more points. Let's take, I don't know, the difference between 11,889 and subtract 9,200, and you can be doing this along with me, and 87. You notice that those are not the same, okay? So there's not a constant difference between any 2 points on here, which makes sense because tuition and board is general trends. It's not necessarily going up by a certain amount each year, okay? And that's why this line is not perfect. But what we can do is draw what's called a line of best fit. And I'm not writing this down, but you may want to. A line of best fit is what it sounds like. It's a line that best represents this data. It relates the points together with a strong linear relationship, even though these aren't perfectly linear. Okay, it's a representation of where they lie. So let me kind of draw this off to the side. If I had a scatter plot that was a lot more spread out, right, that's clearly not linear, but I could draw a line that kind of tries to relate the points as closely as possible. So it might be like right here. It's basically the average of where the points are. Now this relationship we have here is a little bit more linear, so I can draw a line a little bit easier. And again, this is going to take some estimation, which is fine. It may look something like this. And to be honest, yours might be better than mine, and that's okay. It's okay for this topic to make some estimations. Okay, so now that we have this line of best fit, we can use this to find some information. So I've done my sketched line of best fit, and now I want to estimate the slope, y-intercept, and come up with a linear function or equation. Okay, here comes the fun part, which is reviewing Algebra 1. So how do I find the slope? It's a couple things. It's rise over run. Or you can be more specific. It's the change in y. So I'll take my y points and subtract them over the change in x. If you need more help on this, I can derive where this comes from. Just come talk to me. Okay, in order to find that, we need 2 points. So instead of picking my scatter plot points, I want to use my line of best fit because this line of best fit is representative of all the points. Okay, it's my model of trying to get that to be linear. So maybe I'll pick, I don't know, try to find one that's easy, and I'm estimating again. Maybe this is where we're 5 years away at 4,000. I could try and get technical here, but for estimation, it looks like it's in between 3 and 6. I don't know. Maybe I should be more specific. What's in between 3 and 6? Probably not 4, but 4.5. So that'd be $4,500. And maybe I'll pick, and I'm trying to pick points that are close to our values. So maybe I'll pick that this is 25 years away, and we're at about $15,000, right? Again, I'm making estimations, but let's use those 2 points. So if I want to find the slope, I'm going to find the change in y, which our y is our 15 and our 4.5. And I'm going to divide it by the change in x, which I've started here. I'm going to start here, is 25 minus 5. Go ahead and compute that on your own. Okay, so for my slope, I get about 10.5 over 20. So in a minute, we're going to talk about what that really means in this context, because that's the important part of statistics. It's not just having data, but analyzing it. But we'll go back to that. Okay, y-intercept, to review, is where your line begins. Y equals mx plus b. There's a b. B stands for begins. It's your y-intercept. So really, it's asking, like, where are we at 0 here? Okay, it's about right here. And if you want to be real specific, I actually did know where I was at 0, because when we're 0 years away from 1978, we were at $2,918. So the y-intercept we can write as x is 0, y was $2,918. Okay, if you were trying to make general predictions and estimate, you might say 3,000, and that's okay. But I actually did know that value. Okay, so now that we know the slope and the y-intercept, we can write the equation of our linear model here. So there's 2 ways to do this. One is called slope-intercept, which is nice because it tells you what's in this form. If you have slope-intercept, you have a slope and an intercept. So that looks like y equals mx plus b, where m is your slope and b is your intercept. Again, the name matches the model. So if I just plug in my information, I can get that pretty easily. I already know my slope, I already know my y-intercept. So in slope-intercept form, our equation for our line of best fit is going to be kind of ugly, if that's okay. 10.5 over 20x plus our y-intercept, which is 2,918. Okay, just for the sake of remembering stuff from Algebra 1, we can also use a thing called point slope. And in point slope, it tells you what you have. So point slope, you have a point and a slope. So take y and subtract your y coordinate of a point. And that's equal to your slope times x minus your x coordinate of your point. Okay, so plugging in information again, let's see. We know our point could be the y-intercept, or if you're feeling like having fun, you can pick a different point on here. It doesn't matter what point you pick. Up to you. Since we already know our y-intercept, I'm just going to plug that in. So y minus your y coordinate, our y coordinate is 2,918, equals our slope, which is 10.5 over 20 times x minus your x coordinate, which is 0. And you could leave that as it is. That's why I like point slope. Or, this one can be simplified easy. X minus 0 is just x. But I don't care if you leave it in point slope form if we're using that. Okay. So flipping over to the next side, the really important thing is to analyze and interpret this data. So what does the slope represent in this context? So I'm just going to write the slope again. Our slope was 10 point, I forgot already. 10.5? Yeah, 10.5 over 20. Okay, remember this 10.5 came from the change in y. And this 20, maybe, came from, I'm going crazy. This 20 came from the change in x. Change in x. So what it's saying is your y values are changing by 10.5 over time, and your x's are changing by 20 over time. What the heck does that mean? So remember, our y's aren't just a value. Our y's actually represented the cost of tuition in thousands. So when we say 10.5, we're actually saying $10,500. Okay, and our 20 represented x, yes, but x was how many years since the first year we started collecting data? So it's saying 20 years. So what the slope really means is that every 20 years, tuition should, if it follows the trend, tuition should go up $10,500. So slope actually has a meaning in this, and it can be used to help us look at a relationship between two variables, which can help us make decisions. So if I asked you, how much is tuition going to cost in 2020 when you all go to college, or whatever you're going to go to college, then you can make that prediction. So it says every 20 years, it goes up about 10,000. So from 0 to 20, it should go up about 10,000. Does it? So from 2,918 to 11,889, it's not exactly 10,500, but it's pretty close. And again, we were making estimates, and that's why it's not perfect. But you can always put it back into the sense making that way. Okay, there are two more questions here. It's what does the y-intercept represent in this context? And what can this linear model help people do? So when I say linear model, I mean like that equation we just came up, that y equals mx plus b, or that point slope formula. What can that help us do? And I've already hinted at some of these ideas, but I want you to come to class tomorrow with an answer and an idea of how this whole line of best fit thing we're learning about can help us analyze data. Okay, so you can consider these your on your own problems, but think of a deeper meaning in terms of why might I want to analyze data this way, and why might I want these equations? Why would I want slope? Think deeply. And if you have any questions, come and see me. Have a good rest of your night.